Today we're going to focus on ionic bonding. Ionic bonding, remember, is between a metal and a nonmetal. So what we're going to focus on in this particular video is how to actually write chemical compounds. To do this, we first need to review common ion charges. Please get out your reference table and make sure you have the following things written. From the previous video, we talked about groups 1 to 13 through 18, but there's a few more things I need you to add. So group 1 is always 1 plus, group 2 is 2 plus, group 13 is 3 plus, skip 14, 15 3 negative, 16 2 negative, 17 1 negative, and your noble gases are 0. Remember the pattern: 1 2 3, skip 3 2 1. Now, also, you have a staircase here. It's sort of opposite of the metalloid staircase. These 6 elements also have common ion charges. So, for example, silver and gold, when they're forming an ionic compound, always have a 1 plus charge. Zinc and cadmium, always 2 plus. Aluminum and gallium are always 3 plus. Please make note of this in your reference table. So 1 plus, zinc and cadmium 2 plus, aluminum and gallium 3 plus. Now, the metals that are between 3 and the staircase, they do not have common ion charges because they can have multiple charges because of that good old d orbital. There's a lot of things going on in that orbital, so therefore it can change their ions that they form. So you cannot tell the charge of your metals between 3 and the staircase unless you are given a Roman numeral, which we're going to talk about more in just a second. So, an ionic bond is between a metal and a nonmetal. So Na and Cl. Na has 1 valence electron, so it's going to have 1 dot. Chlorine is in group 17, so it has 7. When these two get close to each other, they want to bond. Both of them are very, very unstable by themselves. So, in order to do this bond, it forms an ionic bond because we have a metal and a nonmetal. Ionic bonds transfer electrons. Remember, your metals give away electrons while your nonmetals take them in. It's a give-take kind of relationship. So that means Na is going to give this electron to chlorine. When this happens, you have Na with a 1 plus charge and chlorine with a 1 negative charge. What do we know about opposites? They attract. So this charge difference here, the positive and the negative, causes it to come together to form a bond. And if you had, let's say, another chlorine and another sodium, what would happen? The exact same thing, right? And it's always going to have that 1-to-1 relationship. 1 sodium gives an electron to chlorine. Now, if you take aluminum, which has 3 valence electrons, and oxygen, which has 6 valence electrons. Okay, remember, everybody is trying to achieve or try to get 8 valence electrons. Your metals are trying to get rid of all of their valence electrons, where the nonmetals are trying to get the 8. So in order for aluminum to be stable or happy, it needs to get rid of 3. This oxygen only needs 2. So aluminum gives 2 of its electrons away. Oxygen is good. Is aluminum good? No, so what does that mean? We have another oxygen. Aluminum gives its last electron away. Aluminum's now good. This oxygen, does it have the 8 that it wants? No, it only has 7. So what has to happen? What do we need to add? We need to add another aluminum. When we add another aluminum, this oxygen is able to get its electron. But now what's wrong with this aluminum? It has 2 it needs to get away, or give away. So we have to have another oxygen. Give away, give away. Is everybody stable and happy? Yes, both the aluminums have their electrons given away. All the oxygens now have 8. Now, if I added another oxygen, I would need to add another aluminum. But at the end of it, you should always have a ratio. How many aluminums do we have for every oxygen? Or how many aluminums we have versus oxygens? It's going to be Al2O3. The subscripts are telling you the ratio between the two elements. We need 2 aluminums for every 3 oxygens to cause everybody to be stable. Now, there's an even easier way to do that. You don't have to draw things out to figure it out. I just want you to show you where all this stuff is coming from. So, a few rules. First, you write the symbols for each ion with the cation first. Remember, cation is the metal. So the metal will always come first. Place the charges of each element above the symbol. If there are Roman numerals, they indicate the cation's charge. So you write the symbol, write the charge above the symbol, and then crisscross. 3 main rules. Symbol, charge, cross. Now the thing that's going to get tricky is this piece here. Use parentheses to show more than one polyatomic ion. Your polyatomics are on page 7 of your reference table. Poly means many, so many atoms ion. So it's an ion that contains more than one atom in it. And then reduce if possible. So 3 main. The 4th one is important as well though. So symbol, charge, cross. Examples. Magnesium chloride. So the first thing we're going to do is write their symbols. Now some of you are going to struggle with this because you simply don't like looking at the reference table. Just take a minute and look for it. If you're having trouble finding it, raise your hand and I will help you. Don't get frustrated at that point. So magnesium is Mg. Chloride, this piece right here, we're going to learn more about that tomorrow. The IDE piece, it's added on. So think of it as chlorine. Look at the first part of the word to figure out what element it is. So chloride is chlorine. Step 1, done. Step 2, write the charges above the symbols. Now most of the time, the charges are going to come from that pattern off the periodic table that I gave you, the 1, 2, 3, skip, 3, 2, 1 thing. So magnesium is in what group? 2, so therefore it has a 2 charge. Do not worry about putting the plus or minus. Chlorine is in group 17, so 1, 2, 3, skip, 3, 2, 1. Chlorine has a charge of 1. Step 2, done. Step 3 is to now simply crisscross. This is the part that students, for whatever reason, their brain shuts off, they think too much about it, something's going on. You literally just take this number and put it here, take that number and put it there. So we get Mg1Cl2. Now, your final answer, you do not include the ones. So magnesium chloride is written as MgCl2. Okay, aluminum oxide, same thing, write the symbols. Aluminum, Al. Oxide, remember I told you pretty much look at that first part right now. So oxide, oxygen, so O. Step 2, write their common charges. Aluminum is in one of those 6 that I told you. It is 3. Oxygen is in group 16. It has a charge of 2. Cross Al2O3. Next one, calcium sulfide. Calcium is Ca, sulfide is sulfur. Both have a charge of 2. Crisscross, you get Ca2S2. Now, this is where the fourth part of the steps comes in play. We have a 2 and a 2. So just like the fraction 2 over 2, what would your math teacher expect you to do in this case? You would need to reduce it. So your final answer is CAS. Now, in order to reduce a compound, all the elements must be able to be reduced. Okay, now we're going to bring in page 7 of your reference table. So if you do not have that, pause the video and get your reference table out. Sodium nitrate. Sodium is Na. Nitrate, this 8 piece, means it should trigger something in your brain telling you that it is a polyatomic. Nitrate is NO3. It's on page 7 of the reference table. Now, polyatomics, I'm going to go ahead and tell you, put parentheses around the polyatomic. Do not touch anything inside those parentheses. So you're going to put the symbols and any numbers that are at the bottom inside the parentheses. The number that's on top, you put it on the outside on top. So with nitrate, there's just a little negative there, so that means 1. Sodium is in group 1, so it has a charge of 1. Crisscross. Na1, NO3, 1. But what did I tell you about the 1? We do not need them. Now, when you end up with a polyatomic and you have the parentheses around it, if there's no number on the outside, you can drop the parentheses. So technically, that is your final answer. I will not count you wrong if you leave the parentheses though. Magnesium hydroxide. Magnesium is Mg. Hydroxide. For whatever reason, students get this wrong. We have hydro and we have ox. Ox. Is that hydrogen? Yes. Is it oxygen? Yes. We have the ox piece in there. The X, there is no X in hydrogen. So it's not just hydrogen. Hydroxide is a polyatomic. It is on page 7. Do not get it confused with hydrogen. Hydrogen would be written as hydride. So hydroxide is OH. Again, polyatomics put inside the parentheses. It will stop you from doing careless mistakes later. Okay, step 2 is to write their charges. Magnesium is in group 2. It has a charge of 2. Hydroxide, on page 7, there's a little negative right there, which just means 1 negative. Step 3, cross. MgOH2. Final answer. Now, can I drop these parentheses? No, because we have a 2 on the outside. There's a huge difference between the parentheses being there and the 2 on the outside than having this. MgOH2 written like that is wrong. This is just saying you have 2 hydrogen. This is saying you have 2 OHs, which is the case. So you've got to make sure you put the parentheses. Ammonium sulfate. Ammonium is the only positive polyatomic that we're going to talk about in here. So I literally have students who search the periodic table for a good 10 minutes before they realize that it's not on the periodic table. It is a polyatomic. It's the first one, NH4. Sulfate, polyatomic as well, SO4. Their charges written on page 7. Ammonium has a little plus there. That means it's just 1. Sulfate has a 2 negative, so that means it is 2. Cross charges. Do not touch anything inside the parentheses. So this means we get NH4, 2, SO4. Now technically, this is the complete correct answer. But if you leave SO4 in the parentheses, I will not count you wrong. It's literally symbol, charge, cross. Symbol, charge, cross. Every single time for ionic. Do not make it harder than what it is. Okay, now we're going to talk about those pesky little Roman numerals that I was talking about. These Roman numerals indicate the charge of the metal if you cannot know it simply by looking at the periodic table. So iron is Fe, oxide is oxygen. This Roman numeral tells you iron has a 3+ charge. So Fe is 3. Oxygen, O, is in group 16, so it has a charge of 2. Then you crisscross. Fe, 2, O3. Okay, take a second and try this next one on your own. Iron is Fe, sulfate is SO4. What's the charge of Fe? How do we know the charge of Fe? Roman numeral tells you the charge of the metal, so it's 2. Sulfate is a polyatomic. Put that SO4 in parentheses. SO4 has a charge of 2. And we cross. So you get Fe2, SO4, 2. Look at the numbers that you just crossed. We have a 2 and a 2. What happens to those numbers? It reduces down to FeSO4, which again, there's no number on the outside of the parentheses now, so it would reduce down to FeSO4 like that. Okay, last one, zinc nitrate, zinc. Zn. Nitride, I said nitrate, I meant to say nitride. Nitride is nitrogen. Typically, if it ends with I, it's going to be an element. So nitride is N. Okay, charges. Zinc is in the middle of the periodic table. It's not in the tall columns. So how do we know its charge? It's one of the 6 ions that I told you it has a specific charge. Look at those 6 that I told you the charges to. Zinc will always have a 2+ charge. Nitrogen is in group 15. It has a charge of 3. Cross Zn3 N2. The next video that we will be doing the opposite. We're going to take the formula and you're going to have to give me the name. Please do not make this harder than what it actually is. Okay, now that we've done several examples together, I now want you to attempt these 5 and write the ionic formulas. I will go over the answers in class, so please, if you have any questions or any comments about them, let me know. Pause the video and try them now.